Hello everybody. I'd like to talk about equations that are quadratic in form today. To be quadratic in form, you first have to understand what it means to be quadratic. So quadratic is a second degree polynomial. And so that means that's because this lead term here has a power of 2 on it. And I'm going to go and make a note here. Power on x for the b term, middle term, is 1. So if you're quadratic in form, you're going to have up to 3 non-zero terms. You have 0, then equals. If you work backwards, you have a constant term, a first degree term, and a second degree term. To be quadratic in form, you will have a small degree term, and then the next term over, so in our case, this term right here, the small power is 1 and is double the next power is double the small power. So if it's quadratic in form, it's going to have small power, and the next biggest power will be double that one. So that means when you factor this thing, right, if you factor this, you're going to get x and x something equals 0. So let's take a look here. Example. I'm going to solve, so I want x equals something in the end. And that should be an x. Now if you think about this, my smallest power is 2. Next power is squared, x to the 4th, which is double that. Which means when I factor it, x squared here and x squared over here. Now if you start foiling, right, first term times first term gives me x to the 4th. And then I'm going to do x squared times whatever is over here, which will give me an x squared term, which will add up to give me the middle term here. All right. So we're going to say to ourselves, okay, factoring by grouping, that a times c, or first times last, is going to be 1 times minus 28. We're looking for the factors of minus 28 that could add to minus 3. Probably the most common factors of 28 you might think of are 4 and 7. So we're going to mark that out for a moment. We'll come back to it. So we're going to factor by grouping. We'll go straight to that. To get a minus 28, one of these has to be plus, one of these has to be minus. And I want a minus 3 right here. So plus 4 and minus 7. So x squared plus 4x. I'm sorry. X to the 4th plus 4x squared minus 7x squared minus 28 equals 0. Factor by grouping, x squared, x plus 4 minus 7 x squared plus 4 equals 0. Or x squared plus 4 x squared minus 7. Now if you do a real quick check, right, just make sure we did it right. Foiling, x squared times x squared gives you x to the 4. X squared times 7 is minus 7x squared. 4 times x squared gives you plus 4x squared. And finally, plus 4 times minus 7 is minus 28, or x to the fourth minus 3x squared minus 20. So we did factor it correctly. You'll note, right, that the middle term here determine the first term here and the first term right there. And once I know that, I can actually treat it just like it's a normal quadratic. So here I might ask, can I factor x squared plus 4 or x squared minus 7? And the answer is yeah, but not really easily. So because it's x squared plus a constant, I can just set equals 0 and use the square root formula. So x squared plus 4 equals 0. X squared minus 7 equals 0. Minus 4, x squared equals minus 4. To get rid of a square root, or sorry, to get rid of a square, we got square root, so square root of x squared plus or minus the square root of minus 4, x equals plus or minus 2y. Over here with the x squared minus 7, same thing. 7 is plus 7. We have x squared equals 7. Square root both sides. X equals plus or minus 7. Or if you want to use in set notation, you might say minus 7 plus 7 minus 2i plus 2y is your solution set. Let me know if you have questions on that one. Let's do another here. All right. Is it quadratic in form? Remember, identify all your powers. Find the small power. So here's our small power. Is 1/2. If I double 1/2, do I get 1? In this case, if I take double of a half, I do get 1. So this is quadratic in form, which means we'll end up with x to 1/2 times x to 1/2 somewhere along the line. Because this behaves this way, we're going to just factor it just like before. So we're going to factor by grouping. So a times c is going to be positive 2 times plus 1. So I'm looking for the factor of 2 that add up to this 3 right here. Well, that's going to be 1 and 2. In fact, to get a minus 3, it has to be minus 1 and minus 2. Again, minus 1 times minus 2 gives you a plus 2, and it adds to minus 3. So we're good to go with this. So 2x minus 1 times x to 1/2 minus 2 times x to 1/2 plus 1 equals 0. At this point, it may be helpful to note this. If I have x to the 1/2 squared, that's actually 1/2 times 2 as power, or x to the 1. So when it comes to factoring this by grouping, it may be easier for you to say this to yourself. This is x to the 1/2 squared minus x to the 1/2 minus 2 x to the 1/2 plus 1 equals 0. Now right here, right, the common factor between those two is x to the 1/2. This right here, this first one here, is x to the 1/2 squared, which means I have 2 of them. So I take out a single x to the 1/2. Be 2x to the 1/2 minus 1. And again, right here, if I leave with a minus, I'm going to have to factor out a minus. So taking out a minus, and I want 2x to the 1/2 minus 1. So I have 2x to the 1/2 and a plus 1. So I just take out a minus. So it's literally minus 1. 2x to the 1/2 minus 1 equals 0. And now these guys right there are my common factors. So 2x to the 1/2 minus 1, x to the 1/2 minus 1 equals 0. All we need to do is set these equal to 0. So 2x to the 1/2 minus 1 equals 0, or x to the 1/2 equals 0. Oops, that's not right. X to the 1/2 minus 1 equals 0. Again, recall, we said last chapter, x to the 1/2 is the square root of x. You may find it easier to solve this by putting in square root of x instead of x to the 1/2. All right, let's scroll up here so I have some more space. So 2 square root of x minus 1 equals 0. Square root of x minus 1 equals 0. And when we solve this, we're going to get the square root all by itself. So plus 1 plus 1, 2 square root of x equals 1. Since it's 2 times the square root, we're going to divide. And to get rid of a square root, we square. So I have x to the 1/4 for the left side. On the right side, square root of x equals 1. Square both sides. Or I could say a solution set. This is 1/4, comma, 1. All right. Do you have any questions on that one? Let's try something bigger. All right, this one problem's kind of big. It works exactly the same way as before. If you just ignore everything in here, everything in here, what do you have? You have a constant, something to the 1 power, and double the 1 power gives me 2 power. So it's going to work exactly the same way. Now, sometimes this really hurts people's brains. That's okay. So one thing I haven't mentioned yet, I'll go ahead and do it, put it in here, is you can do something called substitution. Substitution just makes it a little easier to see. So you're going to say to yourself, let's just choose some variable u, And let's replace these two little things here. So what if I call, instead of saying 5x minus 4, what if I say this is 5x, u equals 5x minus 4? Well, if I said that, then this term right here becomes u squared. This term right here becomes plus 2u minus 8 equals 0. Now it's a simpler looking equation. It's going to behave the exact same way, but it's simpler. All right, so factoring by grouping, a times c equals 1 times minus 8. And there's a little bit faster way to do it, but for some of us, we need to see the slower way. So the factors of minus 8, well, it's going to be 2 and 4. To get a plus 2 right here, I'm going to have to do a minus and a plus. Minus plus. So I have u squared minus 2u plus 4u minus 8 equals 0. Factoring by grouping, these two here give me a u. These two here give me a plus 4. These two are common factors again. So u minus 2 times u plus 4 equals 0. What we get? U minus 2 is 0, or u plus 4 equals 0. U is 2, or u is minus 4. Now remember, we have solved this equation. U equals 2 and u equals minus 4. Be careful. Do not stop now. Remember the original equation, I almost lost it up here, is 5x. It's 5x minus 4, right? It had a u value. So down here, I'm not going to stop at u. I'm going to put this back in and solve for x. So I have 5x minus 4 equals 2. 5x minus 4 equals minus 4. Plus 4 plus 4. 5x equals 6. X equals 6/5. 4. Plus 4 plus 4. 5x equals 0. X is 0. Or if you want to write as a solution set, 0, 6 over 5 is my solution set. So your equation can be quadratic in form. It can be very, very simple. Right? This one here is pretty simple. This one here is a little more complicated. This one here looks a lot more complicated. In the end, it's actually not much more complicated than the other two. It just looks a lot worse. So let's do one final example. Choose z to the 4th minus 64 equals 0. All right. This one here is missing a middle term, so it's a little bit rougher. But one of the clues I have looking at this is that gives me an idea. I know that 64 is 8 squared, so 64 is a perfect square. And looking at this, z to the 4th, that actually means, right, if you have z to the 4th, that actually means you have z squared times z squared, which is z squared squared. So you do that, let's screw this out right here. You have something squared minus something squared. This is a difference of squares. So it's going to be z squared, 1 plus, 1 minus, and it's 8 squared, so again, difference of squares is a minus b, a plus b equals a squared minus b squared. And from there, we're just going to solve it like we did before. So z squared equals, z squared plus 8 equals 0, or z squared minus 8 equals 0. Solving for z squared, minus 8, z squared equals minus 8. To get rid of a square, we're going to square root. Remember, whenever we square root, we're going to put that plus and minus in front. So z equals plus or minus the square root of minus 8 is going to be an I, and a is actually 4 times 2. So simplifying that, we're going to have z equals plus or minus I times 2 times the square root of 2, right? Square root of 4 gives me that 2 right there. Or a little prettier, plus or minus 2i square root 2. That's half of it. Still got to do this fellow right here. So plus 8, z squared equals 8. Square root both sides, my plus or minus. And we already know that the square root of 8 is going to be 2 radical 2. There's no I this time because 8 is positive. Or if you like your solution set, we'll do the real numbers first. Minus 2 square root 2 plus 2 square root 2 minus 2i square root 2 positive 2i square root 2 would be that. So that's the basic idea of dealing with equations that are quadratic in form. Let me know if you got any questions.